Data Structures and Algorithm Lab, experiment number 4. In this lab, you are asked to implement a stack using a linked list. Okay. Shortly speaking, linked stack. So for this, uh, this is my code. So before jumping into the code, jumping into the code, let me just explain you the output or show you the output. So first, yes, okay. So fine. As you can see, it is asking one of the four options, either to insert an element, delete an element from the linked stack, or display the element. So first, let us see if it's able to delete an element, then the stack is empty. So let's give 2. As you can see, it pops up an error message, no elements in stack. So that edge case works. So now let us insert some elements. Say 100, I'm going to insert 200, then I'm going to insert 300. Now let's display these elements. So as you can see, the elements as 100 went in first, it was the last to be printed. 200 went in second, it was the second last to be printed. 300 went in the last, it was the first to be printed. So it's like first in, last out. Okay. So display works, insert also works. Okay. Now let's delete elements from the top. So 2. Okay. So element at the top position removed. Let's see if it's true. As you can see, 300 has been removed. Let's delete again. Element in the top position removed. 200 also removed. Delete again. 100 also removed. It's empty. Last time delete. No elements in link stack. So everything works fine. Okay. So now let's go on to the code. Okay. Before that, let's give exit. Hit exit. First thing, to implement the linked list part, that is using a node, for the node, I use a class. This class has one integer variable for the data and other one of type node. It's a pointer to the next node. Okay, so this is a constructor. It has it has one argument d, which is the data which we are gonna initialize the node with. So data will automatically be initialized with d, and the next pointer will be assigned to null. So before going into these functions, let's go on to the main function and see. This code, right? It is used for printing this uh, design, copyright design, as it was asked by the teachers. I have done this design. Okay. That's it. Okay. Now this is where the actual code starts. I have a temp variable to input the choices. Say if you want, like, say, and I'm inputting variables to values to be inserted. That's where I use temp. And this is a top pointer which I initialize to null initially. So a variable choice for the choice that the user gives. So here choice is being inputted. Well, choice is not equal to 4. Here I've given if you give 4, then this while loop will exceed. So if the user gives choice is equal to 4, automatically this will become false, and the controller exit from the while loop. Okay. So here I've used a switch case statement. So if the user gives 1, this happens. If the user gives 2, this happens. If the user gives 3, this happens. And if the user gives any other value, say 5, 6, 7, 8, or any random number, this statement is being printed. If the user gives 4, automatically it breaks off. Okay. So, like after the choice, like if initially user gives 1, then he, like after this is executed, again we ask the choice and input the choice. Okay. If he gives 4, automatically when it goes back to this condition checking, it'll exit. Okay, so that's it. So case 1 is to insert element into the link stack. So first thing we just printing a statement asking the user to enter the value for the link stack. Then I'm calling this function called insert at top. Then passing the top and the value user key. Then delete an element in the link stack. That is that is a top element. Last one to display element. I use function for I use this print function for for deleting. I use delete top function. So now let's go on to the functions themselves. So insert at top. Here I have two arguments. First one is like uh, node star pointer to the top area. This is passed by reference. That is uh, the address of the top value is passed. So whatever change I make to top will actually affect the actual top. Okay. So this passed by reference. This passed by value. So in data. So if top is equal to none, that means the link stack is empty. In that case, we just say top is equal to new node of data. New makes a new object. Okay, node is a class, so new object of this class, and I'm passing this data variable to this class, indirectly calling the class constructor, okay, which automatically assigns the data, and the address is passed to top, and I just give return to pass the control back to the calling statement. If top is not equal to null, then this happens. I'll explain what is this. It's some diagrams. So say there is a value here. Top points to this. So you want to insert a new thing. So what I do is I make a new node calling the same constructor, make a new object calling this constructor, passing the data, initializing data, and passing this address to this uh, pointer n. This is the new node. So n. This is n. So then n of next is equal to top. So n of next will be equal to top. So it will point to top. So top is equal to n. Okay. So the new top. Okay. Just a minute. Instead of drawing this, I should drawing this. There. Just a minute. So this is top T. This is n. So uh, n of next is equal to top. So top points to this. So automatically, if it is n of x is equal to top, will point to this node. Then top is equal to n. So what happens is now I'm pointing top to be equal to n. That literally means top will be equal to this. Top will be equal to this. So that's the logic behind this. So delete top. If top is equal to okay, here also it's passed by reference. If top is equal to none, that means there's no elements in the link stack. So automatically this statement will be printed. Otherwise, what happens is I will show you what happens here. Just a minute. So say this is the top. Say there's one more. Okay. I need to delete top. So what happens? I what I do is I make a pointer of type node star or of type node pointer 0 10. So that will be equal to top of next. Top of next is this. So this will be equal to 10 TE. Okay. So then what I do is I delete top. So if I give delete top, automatically this node will be deleted. Okay. So this also be deleted. So then what happens? Top is equal to temp. So top, if top is equal to temp, comes to the address of this now. So top will be equal to this. That's it. Then element in the top position has been removed. So this is the logic for the second one. Okay, that's it. Print. While top is not equal to null, until top is equal to null, we'll just print the top of data and it just change to top of next. I'll just give you a visual representation. Say two nodes. Initially top is here. So initially print top of data. Then what it does, top is equal to top of next. So here top is changed to top of next. So a point to note here is I've used call by value, not call by reference. So what you do is you just pass a copy of top, you just make a copy of top and do it, but it won't change the actual value of top in the calling function. So that's it for the print statement. That's all for the program. Thank you. Let's stop the recording.